Hello everyone, and welcome to It's Not the Oven's Fault, 5 Costly Drying Process Mistakes and How to Avoid Them, presented by Dr. Zachary Cartwright and Dr. Susan Newman. Today's presentation will be about 30 minutes, followed by about 10 minutes of Q&A. If you do have a question for Dr. Cartwright or Dr. Newman, simply type it into the questions pane at any time during the webinar. We'll be keeping track of these to answer during the Q&A, so please don't be shy and submit those questions. Also, we'll be sending out a link to the on-demand webinar as well as the slides for you to review as soon as they're available. So, without further ado, I'll hand the microphone to Dr. Cartwright.
Thanks for the introduction, Brad. My name's Zachary. I'm here today with Susan, and we're here and excited to talk to you about 5 costly drying process mistakes and ways that you can avoid them. Now, whether you're baking or dehydrating, maybe smoking or drying or curing, whatever your team calls it or whatever that step is in your process, it comes down to one thing. You're basically removing water, and a lot of food companies do this, but any food company that does this will tell you that it's really hard to be precise and to be consistent. And although there are hundreds of different topics that we could talk about related to drying, we're going to try to summarize it to the top 5 mistakes that we see. So these mistakes are misunderstanding the correct measurements that you should use, using the wrong method for that measurement, letting operators work on intuition and maybe using their hands to make really important decisions, sampling in the wrong places, and then also leaving your control loop open. So we'll walk through each of these today. All right, before we look at the 5 mistakes, I just want to talk about how much is at stake and the cost of inaction. So what it's costing companies to not be really focusing on their moisture content and reducing that variability and hit their target over and over. So we have a figure here that is looking at the cost of inaction. On the x-axis, you have weeks that are going by, and then on that y-axis, you have what this is costing companies. And this example is for different pet food products, and you'll notice that every week that goes by, this is costing tens of thousands of dollars. And we see this in pet food for lots of other products as well. So this is before anything has been implemented, and a lot of companies aren't even aware of what it's costing them to have a high degree of variability in their moisture. What have you seen, Susan, in your experience when you go and talk to a client? Are they aware of these figures, and what's it costing them?
Yeah, great question. So they are aware, but they are under aware. So they underestimate where they're at. Mm-hmm. So this is actually one of our clients that we did just looking at where they were at before we came and did the installation. And they were underestimating by about 80% on where they were actually at. So it was huge. They knew there was an opportunity for increasing yield. Mm-hmm. They thought it was going to be pretty small. When we came in and really started looking at data, because data is hard in food, a lot of times it lives in a paper record. Mm-hmm. So really digging into that and putting in the energy to see that, what we saw was that this was almost 8 times what they thought it was. So people are often underestimating where they can be by controlling that process. And this is an example from pet food where the cost of ingredients is quite low. And we see this in customers that are using whole muscle meats, for example, cannabis, where the cost of ingredients or product is much higher. So you're looking at something that is cents here. This costs cents for ingredients versus cannabis, where you're looking at, depending on the market, 2,000 per pound. Sure. Or meat right now is very high. You're looking at $8 is pretty average for a price there. So this is exponential for those markets.
And that kind of brings us to our first mistake. And what I notice among a lot of food companies is that they're misunderstanding the correct measurement that they should take for their water. So basically, water measurements can be summed up into 2 types, either moisture content and water activity. And I just kind of want to take some time and note the differences between these 2 measurements. And before I go and look at this comparison, what do you see, Susan, when you go talk to a client? Are they using one of these or both of these, and how are they being implemented?
I see everything. You can't even imagine what I've seen, from NIR to moisture balances to people doing labs, Carl Fisher, things like that. A lot of water activity as well. But industries kind of drive that and what they have for their CCPs and what they require. So pet food, for example, heavily into moisture as a CCP for that. A lot of our companies are understanding the importance of water activity for safety parameters, so they're using that a little bit more. I love seeing that. But honestly, this balance, so a lot of companies are really starting to understand this, and I love that. We have a long ways to go, though. So I see a lot of moisture balances out on floors that people are using. So we got to understand why we're taking that measurement. I see a lot of water activity typically in the lab, not so much on the production floor. So what I would love to see is this meld in understanding why we're doing it. I had one client that I love telling this story because it's so fun. I met with the CFO and super excited about moisture content. So in the lab, you would see 10 moisture content devices, 1 water activity, and QA team. So we have a QA team leader. Her name is Teresa. Love her. She just loved this water activity meter because she understood where pathogen growth occurs. She understood that bacteria are not growing under 0.8, no molds or yeast are growing under 0.6, nothing's growing under 0.6. She also understood that it was water activity as the driving force for crispiness. So if you're making a crunchy product, you need water activity in your life, and she understood that. CFO was really leaning into moisture content because that is yield parameter, and he's right. If you're running a business, you need to understand moisture, but you also have to make a safe product. So understanding these two measurements and using them appropriately is somewhere where we really need to get in food.
And we have a table here that I think really helps to summarize the difference between these two measurements. So water activity is a measure of energy. It's a thermodynamic principle, and that energy is important because it helps us understand if certain chemical reactions can occur, or if microorganisms can grow, or if texture can change. Moisture content is simply an amount. So if you were able to remove every molecule of water from a food sample or from a product, that would be the moisture content. And that is extremely difficult to do, to remove all of that water and get an accurate reading. Water activity is qualitative, and what I mean by that is even though we get a quantitative number, it's qualitative because we can relate that right back to safety and quality of that product. I see a lot of companies try to take a moisture content measurement and relate it back, but the inherent variability in moisture content makes it extremely difficult to do that. So moisture content is more quantitative, just like you said, a CFO or a decision maker thinking of how much this is going to increase their yield or revenue is going to be interested in moisture content. Water activity is a driving force for chemical reactions and other things. Moisture content, even though there's a relationship there, it's really hard to understand that relationship. And water activity is much higher precision and accuracy, so it allows us to make the determination and relate it back to safety and quality. Water activity, we have known standards for. These are different salt solutions that have the same water activity every time, so it makes it really easy to verify the calibration of a water activity instrument. Moisture content, it doesn't have these types of standards. There's nothing that has an inherent moisture content that we can compare to, so it's really hard to know if you're even getting an accurate number or not. And then finally, water activity is unitless. It ranges from 0, something that has no energy, all the way up to 1, something that has the same energy as pure water. When we talk about moisture content, this is generally expressed as a %, either on a wet basis or a dry basis. So hopefully this table helps you to understand some of the differences between these two water measurements. All right, let's go ahead and move into the second mistake, which is simply using the wrong measurement methodology. So whether you're using water activity or moisture content, there are different methodologies for each of these. And it's really hard to control a process if there's a lot of standard deviation and a lot of variability inherent into the method that you're using. And we have a graphic here that's going to show one product where we use different methodologies and the results from each of those methodologies. So here on the x-axis, you have different methodologies, and it might be a little hard to see, but basically we were looking at an oven method versus the true dry versus moisture balances, as well as Karl Fischer titration. And then on the x-axis, you have moisture content as well as water activity. And the first thing that I want you to note is that even though this is the same exact product, that moisture content is all over the board. And if you look at the water activity, it's very consistent, almost no change in water activity, even though the moisture content measurement is giving us a high degree of variability. And why is this important, Susan?
Yeah. So when we did this study, I was so excited. We took a product, brought it all to a point where it was all acclimated and perfect, ready to go. So you'll see that water activity, very consistent, 0.42. We sent it off, looked at different moisture content readings. I was so shocked to get these results. So you'll see the lowest we've got at 3.5, and the highest is almost 10 from the same product. And I tried to put myself into our QA team's shoes. How would they feel if they got these results, and what actions could they take from these? And when you get these results that are so varied, I felt defeated for them. If you get the reading, say you only send this out to one lab, you only get the 3.5. What do? You think that you are over drying your product, so you're adding more moisture, you're reducing temperatures, maybe decreasing cook times, which can mess with your CCP of kill steps sometimes if we're not too careful. And then on the other end of that spectrum, if you get a reading back of 10 and your product can be up to 12%, which this product was, it was a 12% top limit, you get that, you think, wow, I'm doing a really good job. But looking at all of this data, I was just shocked at the variance that we saw in this and how hard it is to really do a good job every day to make sure that your product is coming out consistently.
And we recently had a webinar on moisture measurements, and something that stood out in that webinar once we had collected some data is just how much variability there is, especially for moisture balances. This kind of goes back to what you said earlier. A lot of facilities that we serve might have 10 moisture balances and one water activity meter, but that moisture balance can have a variability of 4 to 7%. That's really usual, and that can be because of a different person using it or a different methodology or so on. And I think this graphic also does a good job of showing that variability. So what would you do if you were that QA person, Susan? What would you do after seeing this data? How would this inform you to make a decision about the method that you should be using?
Yeah, so seeing these individual data points would be huge for me, but seeing all these together makes me, I've always known that water activity is critical for us to understand just due to its accuracy. I do see moisture content varying with my clients, plus or minus 2% is just across the board, but even up to 4 to 7, like you said. If I saw this data, I would be shocked and really start questioning my methods and look to how can I do this in a better way, and what is the truth? And how can you really lean into some of these more accurate measures, such as water activity, but still apply them to moisture content, which is a CCP, which is also really critical for your yields and for your profits. So for me, I would really want to lean into this water activity, but understand the difference and the relationship between the two. And there is a relationship. So I think that's where I would spend my time looking at all of this data. But man, if I just got one of these data points, I would think I was doing awesome, or I would think I needed to be fired.
And I think it's important to note that there is actually a relationship between water activity and moisture content, and this is something that we're going to touch on in the next mistake. So let's talk about the third mistake, which is letting operators work on their intuition instead of using real-time accurate data for them to make an informed decision. And I think you have some good stories about this, Susan, so I'll hand this over to you.
Yeah, I think I spend most of my time in mistake number 3. I have a lot of operators, especially ones that have been there for a long time with the tribal knowledge. I had one of my favorite customers. I hope he's watching today. Hi, Harley. But he was working on a line where they were making a dog biscuit and making a dough to start. And he was convinced that he could reach into that dough and feel it and tell if it was going to run well or not. And I challenged him on that because I think really what he was feeling was temperature. As you die roll, the colder product comes through a little bit nicer. But hands just are not calibrated to do that kind of work. So if you're relying on that, call me. We don't want to do that. But that was really common. And even QA was on board with this because that wasn't a point in the process where they were really measuring anything. It didn't really matter as a CCP. So for him, that intuition, and then training people. How do you train people the sense of feeling, right? So working on intuition not always the best idea. So that's my first example. Another example that I see oftentimes is in cannabis, where if we look at historically, there wasn't a lot of science in cannabis. There was a lot of snap testing. I typically see a snap test, if a customer's doing that snap test, about 0.4 water activity is where they're going to get that feeling. And I've done a lot of testing on this, where they're going to get that feeling of a snap on the branch. So 0.4, and that's a problem because 0.4, you've already degraded terpenes in product. We know that at 0.5 water activity, terpenes start to degrade in cannabis. So if your average is coming out the door at a 0.4 water activity, you've already degraded terpenes in that product. And you'll see this same thing in chips and other things. If you overdry, you start losing quality. So this graph that we're showing here, the sweet spot graph, the red zone is the ideal. And this is an ideal for a cannabis. And this is actually a cannabis isotherm showing the relationship between moisture and water activity. And I want all of our clients to hit that beautiful sweet spot. That's the point where we're safe from pathogen growth. We don't have much growing on cannabis under 0.625. And the one we have to look out for there is Aspergillus enchilatus. That can grow down to 0.625. But I still want them to have this beautiful yield. So we want to keep them between 0.55, where terpenes are nice and beautiful, and then an upper limit of 0.625. So by hitting that, that's where they're going to have this beautiful product, but also the most profitable product to sell as well. So if you look at this relationship between moisture and water activity, if you're using a snap test, you're typically coming in at about an 8% moisture, versus if you're relying on a more accurate method such as water activity, you're going to be able to get this precision that you need to be able to dial it in here, and up to 12% moisture. So for cannabis, a 4% increase in moisture, even if you're doing 50,000 pounds a year at a sale price of $2,000 a pound, you're looking at this being a $4 million problem by optimizing that 4%. That's an extreme, right? Because of the value of the product, but we see this all the way down to even our low value products where this is happening. And another really cool thing about understanding the isotherm, that relationship between moisture and water activity, as you can see, and going back to Harley, the reason Harley wasn't very effective is you can see that this large change in water activity is only a small change in moisture, right? So moisture doesn't really change that much, where water activity is changing a large amount. So that's why hands don't work, and that's why relying on water activity as your measurement of choice here is the best.
And I think it's important too to understand that this moisture sorption isotherm that we're looking at, this is actually something that Meter Group specializes in. We have a patented technology that allows us to either make a desorption curve and understand how water is removed from a product, or an adsorption curve and understand how water binds to that product. And then using that curve and setting a target for your water activity, then we can find that sweet spot and kind of please everyone. We can make the QA person happy that understands the science so that they know their target, and also understand what that moisture content target should be. So this graphic does a really good job of kind of summarizing everything that we need to know about the water in that product, making the scientist happy as well as the decision maker, and understanding what that sweet spot should be. So this is something that we can make for every different type of product, or even every formulation of that product may have a different curve that we need to consider. Let's move into mistake number 4, and that's simply sampling at the wrong spot. So Susan, when you go into a food facility, where do you see people sampling, and where should they be sampling?
Yeah, awesome question. I typically see people sampling post-cooler. So in this example, so before it goes into a package, that's typically where their CCPs are for a product. So we'll see a lot of heavy sampling in that area, and then some sporadic within the process. I've got some clients that are really starting to understand the variance in ingredients and how that affects the dough. So in this cookie example that we're showing, we've got a dough area where we're doing the mixing of those raw ingredients. We've got an oven, and then we've got a cooler. So understanding the mixer, so dough is typically 0.99, pretty close to what you'd see for water. And then at that cooler for a cookie, to get that nice crunch that you might want, that's about 0.3 water activity. So by getting those two areas, that gives you one view, but the part that's missing is the most important part, and the part that takes the most energy to run, and that's the oven. So what I love to see is clients that are branching out and really understanding a target for each process. So dough is one process, the oven is one process, and then cooling. And then we could expand this also and look at how you're storing after you cool it before into the package. So depending on where you're at 0.3 water activity, if you've got a really dry environment, you could lose moisture, versus in a humid environment, you might actually gain moisture and push this above where you've got some gross cookies that aren't crunchy. So understanding each of these processes, I think, is really important.
And I think something that's actually missing from this graphic is that I notice a lot more companies measuring incoming ingredients. So a lot of companies now will set a spec, maybe plus or minus 10% for water activity of incoming ingredients. And the reason for that is that any variation in your incoming ingredient can be carried through to that final product. So I think that's becoming more and more common. Have you seen that in your experience with some companies?
Yeah. One of my favorite, that's why I'm over here smiling. One of my favorite clients is Sunrise Fresh, and they have a family farm. It's just awesome. So they're growing cherries, walnuts, and things like that. One of their products that is most troublesome is the cherry. From year to year, and I didn't even think about this, but from year to year, depending on the amount of water and sunshine that cherry is getting, changes the Brix level of that cherry. So now they're coming in and looking at that cherry and doing an isotherm on it to understand how that change in Brix affects that cherry. And if you're just putting a cherry in drying it and putting it in a bag to munch on, that's one thing. But if you're using that cherry as an ingredient in another product, like an energy bar, for example, then it has a bigger impact because sugar is such a strong humectant. So that's a fun way to look at ingredients. A small change from year to year variation in cherry can be a big change in a granola bar.
And I think it is important to note that we can make an isotherm, whether it's every season or every formulation. That isotherm really helps us to pinpoint the sweet spot, kind of going back to our previous mistake. And again, we can make that isotherm for every product or formulation and then use that information to set the target correctly. Something else that I think that we could note about this figure is that I do notice some companies using benchtop water activity meters to try to get an in-process measurement, and it can be somewhat effective. But if you are pulling a sample and if you're having to wait for the temperature to come to the right temperature, or if you're having to do a lot of sample preparation, even if you're taking a 1-minute reading on the Aqualab 3, it might be taking you 20 plus minutes in order to get a reading. And by that time point, it's already too late, that the changes have already happened and you can't correct effectively. So why is it so important to be able to take an in-process measurement?
Yeah, exactly what you're talking about. If we don't know, ignorance is bliss. We just keep running, and we're running product that is maybe out of spec. Maybe it hits your spec for a CCP, but it doesn't have the quality that you want. So by understanding exactly where you're at and quickly getting that feedback and making these micro adjustments is perfect, and that's where you want to be. And I think 20 minutes is too long. We're running belts because we've got these industrial dryers. We're running belt speed at as high as we can go because we want that throughput. So 20 minutes can be a huge amount of diversion and rework. I like to see this instant, and if you can close that loop, even better. And I think that's something we're going to talk about next too.
All right, so our fifth and final mistake is leaving your control loop open. And what do you mean by this, Susan? You kind of touched on it earlier in mistake 4, but what do you mean to have an open loop versus a closed loop?
Yeah, pandemonium is what I mean. By leaving your control loop open, that means that you're just running product. You probably know that for a cookie or whatever your product is, you know what the time and temperature recipe is for that. So leaving the loop open just means that you're setting those parameters and you're just letting it run until there's a problem. You're not really optimizing. And where I really want to see clients thriving is in that point of variation reduction, and just generating a product that is really tight to their spec. So you'll see in the graphic here, this is actually an example of our Scala Solo system running. And in this, we're able to actually close the loop on a process instead of just letting it run. Variability is the enemy. If we have a lot of variability, we've got a lower yield, we've got a lower throughput. It's costing more to run those ovens as well. A lot of rework, people are expensive. And then where are you going to hold it? You also have to hold this product. And then when you hold it and it's out of spec, it can lead to mold issues. So now it's something that you have to throw away. And then your customers aren't going to like it either, right? And they don't want to have a moldy cookie. So by closing this loop and understanding, we know all this data. We've got a historical record with a product like Scala, or there's a lot of systems on the on the market that can give you that historical data, but understanding what that looks like and making those changes quickly. You can't do that if you're a human. You have to do that by looking at data on a second-by-second basis and then knowing precisely when to make an adjustment so you're not throwing your system out of balance.
And just to clarify, the open loop system is still dependent on a human, and of course there's going to be error then associated. But this closed loop system is still being monitored or watched by an operator, but those quick adjustments are being made by the instrument itself or by the machine. Maybe you can talk about that just a little more.
Yeah, certainly. So the Scala Solo works we're looking at temperatures within the system, so inlet, outlet, and product temperature. And then we've got a patented algorithm that is so we understand in-process moisture, water activity, and we can do both. And I like to train this, and we train this around water activity. So you'll see on this PLC example, there's a spot here that says the water activity target. And what we're looking at here is I want this to run on that target, and then operators are going to take a sample to verify that algorithm is running efficiently, and then it's making adjustments all the time. And they're micro adjustments that don't have a huge impact on your overall process that you validated with your R&D department. So we want to just look at second by second data and then every minute making the decision to make a micro adjustment. And not just that, you'll also see here that there's multiple zones. So which zone has the biggest impact on that outcome that you're trying to achieve and adjusting in that zone. So we've talked about water activity and moisture content, but now we're bringing this all together, looking at historical records and how we can really bring Industry 4.0 data to make real-time, fast, actionable outcomes for operators.
And I think one way to understand this is if we allow this PLC to play, and if you watch the animation with it, you'll notice that there's a certain target and it's lower than optimal and a lot of variation. But just 30 minutes into implementing Scala Solo, you'll see that variation reduced, and then you can actually increase that target. And this goes back to our very first graphic of what's that cost here, or how much this is costing companies not to be able to make that adjustment. And I think this graphic does a really good job of showing how powerful Scala Solo is to very quickly reduce that variation. What product is this for, Susan?
Yeah, this is actually a extruded pet kibble, dog food.
And so from here, I just kind of want to move on and ask about operators. So, how can you have a brand new hire be just as good as that person who's been in the industry for 30 years? Does this tool allow that to happen?
Yeah. I mean, nothing is magic, but this tool definitely kind of takes that decision making out of a human's hands, and really it's doing that for them. So it's going to make these adjustments in a closed loop system connected straight to a PLC. So getting that PLC data, which could even be at the micro level, that PLC data comes in, we're reading that, understanding those inlet, outlet, product temperatures, and then we're automatically adjusting. So even your newest operator can be very effective at running a system. Now, there's always going to be, from device to device, startup and shutdown is always going to be difficult. So we help navigate that as well by helping them to really focus on how they do a startup and a shutdown, and then we can take it from there. So essentially putting their process into cruise control.
All right, to wrap things up, I just want to move through the 5 costly mistakes one last time that we looked at. The first one was misunderstanding the correct measurement that you should be using. The second one was using the wrong methodology for the measurement. The third one was letting operators work on intuition, and we went through a couple stories that Susan had. The fourth one is sampling in the wrong place, so not just sampling the final product, but sampling throughout the process. And then the final one was leaving your control loop open. So if you have any questions about any of these topics that we went over today, or questions about water activity or moisture content or isotherms, and questions about Scala Solo, please reach out to us, visit our website, or reach out to Susan or myself directly. We'd be happy to take your questions. We do have a couple questions here now, and we'll go ahead and open the floor for those questions and answer as many of them as we can.
Thank you, Dr. Cartwright and Dr. Newman. All right, so we will use the next 10 minutes or so to take questions from the audience. And thank you again to everybody who's sent in your questions already. There's still plenty of time to submit your questions, so please do not hesitate and submit yours. We'll try to get to as many as we can before we finish, but if we can't get to yours, don't worry. We do have them recorded, and we will contact you within a day or so to discuss your question. to start off, it looks like we've gotten a lot of questions about drying specific products. So soft dog treats, cannabis, powders, soft gels, kibble, seafood. I'll stop there, but can you speak a little bit about the differences and commonalities you've seen in the way different products dry? And then along with that, is a product-specific drying approach always necessary?
Nice. Well, I'm ready to go. Can you speak about these differences and commonalities? I mean, pathogens are pathogens, and where they grow is really specific to that pathogen, not the product. Mm-hmm. So, we know bacteria are not growing below 0.8, yeast and molds below 0.6. So that's the commonality. The difference is really understanding the product. And we talked about, looking at the isotherm, that difference between moisture and water activity is different for every product. So the way that you get to a safe point is going to be different for all those products and specific to that product. So we see this a lot in, we shared the example of cannabis and how that dries. So that difference really is understanding where to go fast and where to slow down. For, maybe a cookie, it's a real quick process. You don't have to worry so much about microbial growth. When you're working with a product like a salami, that might be a 30 or 90 day. We want some bacteria to grow in there, but we have to do that in a safe way as well. Mm-hmm. So across the board, these differences exist. In cannabis, if we go too fast, we actually kill the terpenes on the outside of the product where the inside is moist. So in terms of speed, that's really where the differences lie.
And I think it's a good point that even though the targets may be the same for some of these different products, the way that these products lose water or even gain water is really product specific or even formulation specific. But using that isotherm, this is something that we can understand and help you to set your targets. And then it can also depend on the methodology that you're using, whether it's a spray dry method or batch oven or something else. We are able to look at each of those methods and effectively help you to reduce that variation and hit your target.
All right, our next question asks, what advice do you have for someone trying to dry high moisture products as quickly as possible? And for high moisture, they're talking about 60% moisture content or greater.
Sure. Well, generally products with that high of a moisture content are things like dressings or maybe jams or something that are much higher in moisture. Sometimes if you're working with a dough or something like pet food, something that you need to be careful of is that if you dry too quickly, that you can actually get encasement where the inside of that product has a higher moisture content, higher water activity than the outside. And then once that product can reach equilibrium, then you start to have problems with microbial issues. So I'm not exactly sure what the product of interest is here, but I will say that for certain products, you do need to be careful not to heat it too quickly. What's your experience, Susan? Is there something I'm missing here?
Yeah, I think we need to look at hurdle steps in here. So hurdle technology, looking at, I'm interested in what kind of humectants that you might be using to help reduce that water activity for more of a stable, safe product so you don't have bacterial growth. Also, maybe pH. So you might look at pH as a part of your hurdle technology as well to make that a little bit safer from pathogen growth.
This next question says, I work with snack foods. In terms of SPC, what attributes should I use to measure and control to reduce process variation?
Yeah. Okay. So we've talked about this quite a bit. For looking at process variation, you have to have a really good way to measure a great yardstick, and you do that through accuracy. So for process variation, you have to look to water activity, and you can get this accuracy of 0.003, 0.005, which is in our TEs and our Aqualab 3. And for moisture balance, we showed today that we saw readings all over the place from 0.35 all the way up to almost 10. So if you're looking at statistical process control in your process, you have to look at a really great way to measure, and that's going to be water activity for you. Snack foods, especially, they need to be shelf stable. The only way you can look at that is through water activity. And that's going to be the attribute that you want to establish for each step of that process. So from your mixing to your cooking and your cooling, and then before your packaging.
And this kind of goes back to the isotherms again. A lot of snack food products in that sweet spot that we've been talking about, a 1% change in moisture content can be a 30 or 40% difference in water activity. So it makes sense that you want to use the measurement with the highest degree of precision and accuracy, and that's going to be water activity every time.
Well, it looks like we're hitting up to the end of our time here, so we'll take one last question. And this last one is, what parts of the drying process are most likely to promote microbial growth, and what can be done about it?
The beginning is the answer, I think. So the parts of the drying process that can promote microbial growth, I see this we looked at the cookie example, and I've seen this where they're using a batch process. They're mixing all their ingredients, adding their water. It gets pressed or formed, however, and then it goes through the oven. And then they put in more ingredients, but they haven't done a thorough wash down. So I think the first part of this is really making sure that you have a great sanitation program, making sure that you're washing down as frequently as you need to, swabbing to see if you've got growth and where those high growth locations are located. You'll see that in typically places that are hard to get to. The problem is they're hard to get to, so people don't clean them. So I do see that quite a bit. And then what can be done about that? Looking at your programs, looking at your shift changeover, that's really where I'm leaning to, as well as getting your product below spec for microbial growth. So unless you're using a kill step in there, you're not killing anything, but we want to get it down to a point where it's not growing and multiplying. So again, bacteria, 0.8, your yeast and mold, you're just going to be pounded into your head, 0.6 for those. So getting to those limits as quickly as you can and maintaining them there too.
And the only thing that I'll add to that is, even if you get below those limits, keep in mind that the conditions of your facility can promote microbial growth if the humidity is high, if the temperature is high. Even if you are below the limits that Susan just mentioned, you can be in an environment where the microorganisms are already there, and then once the environment is allowing for growth, then you're going to see a bloom, and you're going to see these microorganisms start to grow. So keep that in mind. Even if you control through the drying process, that product, if it's close to a limit, still needs to be monitored very closely.
Great. Well, that's going to wrap it up for us today. Thank you again for joining us, and we hope you enjoyed this discussion as much as we did. And thank you again for such great questions. Please consider answering the short survey that will appear after this webinar. Look for the recording of today's presentation in your email, and stay tuned for future Meater Food webinars. Have a great day.